Alright everybody, so I promised you I would make a video where we add some extra stuff to this circuit. I'm going to try to add, well, we have 27 minutes before class starts, so I'll see what I can add to the circuit in that time. I'm going to try to add 2 buttons and a piezo buzzer. So we'll try to add a piezo buzzer. I'm not sure if I'm going to be able to buy these, but if you wanted to add a piezo buzzer to your board itself, at the very least we could desolder it. So they're fairly simple designs. So let's go back to our strain gauge circuit, and let's consider adding, let's assume we're going to add 2 buttons and a buzzer. So the first thing is, if we're going to add, so we have 2 LEDs, we're going to add 2 buttons and a buzzer. We can't use a 6-pin header. We're going to have to add, for the 2 buttons, 2 extra pins, so 7, 8, and then a 9th pin for the buzzer. So we're going to delete this. We're going to go design, update PCB again. It says no, keep going. It wants us to save. It's freaking out a little bit. Update PCB. No, keep going. Okay. So it's going to get rid of that connector, just like we did in video 2. So we'll go back and we'll add a 9-pin connector. So to do that, once again, we go to JLC. Oops, sorry. Go to LCSC. And we do search for 109. Pin headers. Okay, well, I don't see any good ones, so we'll just go back to connectors. Pin headers, and then we'll go to pitch, 2.54, number of pins, 9. Let's see if any of these. Okay. 9-pin headers, search by availability. Okay, so we'll try this one. So we'll try to grab this one. We got it. All right, we'll go place. So we'll put, well, I want to move that ground, so like that. Okay, so now we have a 9-pin header, and I'm going to actually move this back a little bit, just to give ourselves more space. Okay, so first thing for the buttons. So for the buttons, there's lots of surface mount buttons. We have a lot. There's kind of a standard footprint though for buttons. You can do surface mount, you can do through hole. Let's go back to JLC and just find a popular one. The type of buttons we're looking for, let's do products. So these are tactile switches, are typically what these are called. So dip switches, so tactile switches. And I'm tempted to, when we look at tactile switches, just immediately sort by availability, see what's most popular. We're going to see the standard footprints here. So yeah, so we have, this is a standard surface mount part, standard footprint surface mount part. These are a little tiny. Let's, we could go with one of these. Maybe let's try to find a through hole. I know we have both the through hole and the surface mount part. Let's go with these. This is our standard button through hole. This looks pretty standard here. I gotta zoom back out. So it's this guy right here. Here's the part. So if we go back to the library, see if we can find that. Oh, I messed it up. I accidentally hit Control Copy instead of paste. Nope. There we go. Looks like we got it. So we'll place that. So what we'll do is we'll place a couple of buttons. We'll just place one here, one here. So the way these buttons work is they have 4 pins, and there's 4 pins for mechanical housing, because you want to have, if you had 2 pins, it would kind of possibly be able to wobble. The 4 pins give a good mechanical connection, but 2 of the pins are always connected together. And what I've found is it's always best to just wire these together. So wire the 2 pins together just so that it makes sure that they're connected on the PCB. There's really no reason not to do this. Now with buttons, there's a couple ways to go. We could just connect one side of these to ground and the other side to the pin and be done. And then as long as the Arduino is set to be input pull-up, it's fine. As long as the Arduino is set to, so we set the input to input pull-up, then hitting this, then if the button's not pressed, it would show a 1. If the button is pressed, it would show a 0. If we want them to function the way the buttons work with the seed buttons, then we have to use a pull down instead of a pull up. So pull down resistor will keep this thing pulled down until you push the button. So it'll keep it low until the button gets pushed, at which point it will be, it'll go high. So, or no, it'll keep it pulled. So it'll be, yeah, pulled down if the button's not pushed. It'll be pulled up if it's high. Okay. So to make this a pull down, what we're going to want to do is we're going to add another resistor. I think we already have resistors here though, like good ones that we can use. So let's just do, we'll just do the 20K here. So we're going to take this 20K and we're going to connect this side of it to ground. So this side will be connected to ground. And I apologize because this is getting a little sloppy here. I'm just trying to go fast. So now one side of these buttons is always connected to ground. So if we connect this side of the button to the connector, it will be low. And then if the other side is connected to high voltage, so if the other, oh, we got to move it. Oh, I screwed up this thing. I screwed this thing up. Uh-oh. Yeah, you see what I did? These are now wired wrong. I messed it up. Okay, VCC has to be connected here. And then we have, okay. This does not bode well for me getting to class on time. There's probably a better way to do this. I just don't know the software well enough to know what that way is. Okay, so now we're going to connect this side of the button to the next input over here. And this side of the button to, well, I might as well just go through here. And this side of the button to this. Okay, so you can see now, when these buttons aren't pressed, this signal is going to be connected to ground through the 20K resistor. In that case, the other side of the button needs to be connected to VCC. So now these are going to function. So when the button's not pushed, the signal on this pin is a 0. When the button is pressed, it connects VCC through this resistor, but this voltage will still be VCC. And it'll be burning a little bit of current while the button's pushed, but it's fine. It's just through 20K, it's not a big deal. So this is fine schematic-wise for getting these buttons to work. Now the next thing is the buzzer. The buzzer that we use, the buzzer that's used on the board is basically if you apply 5 volts to it, it'll make a buzzing sound. But it possibly draws a lot of current for a GPIO pin. So what they do is they use a transistor. So if you look at this buzzer, so this buzzer looks like they added in 2004, this S9013 transistor. So if we look at the S013 transistor right here, so this is a BJT, which doesn't necessarily mean too much. 500 milliamps NPN transistor. Okay, so NPN transistor. So we'll just add this. So what they're doing is, this buzzer, what they're doing is one side of it's connected to 5 volts, to the high voltage. And the other side is connected to ground through a transistor. So when the microcontroller outputs a 1 or a high voltage, it'll actually turn on the transistor, which then allows current to flow through the transistor. The benefit of that is it means all that current is not flowing through your microcontroller. So we're going to do that. So we're going to go so So first of all, we'll put this S9013. The most popular one here is this. These are all pretty popular, but these are all pretty popular. We'll see if this is there. Yeah, it looks like that works. So we're going to place that. So we're going to place this down here or so. Again, we're getting a little sloppy here. So this transistor is going to be used to connect to, if we just search for a normal NPN transistor, yeah, so normally the emitter is connected to ground. Yeah, so this is basically what we want, right? This is what we're going to have. Is we're going to have our speaker connected like this, an NPN transistor, and then a resistor. NPN transistors require a little bit of current. So NPN transistors are current amplifiers, unlike a MOSFET transistor, you apply a voltage and it turns on or off the gate. A BJT transistor, you apply a current and it amplifies that current, typically by like 100 or something. So I think on the, if we look at the Seeed Studio, this resistor here, I looked on the one that we have and it said 10.2. The resistor said 10.2. Now I believe that means 10 times 10 to the power of 2, so that should be 1,000. But we can double check just for fun. We can do 102 resistor SMD, just check. 102 resistor SMD. So yeah, that's 1 kilo ohm. So we did verify this 1 kilo ohm. So let's go back. We're already using a 1 kilo ohm resistor here, so we'll just copy this. Press R to rotate it. Okay, so we're going to have this pin now. Drive the resistor here. This side is going to be connected to ground. And then the other side has to be connected to our speaker. Now, my question is there a speaker? I didn't check this beforehand, so surface mount buzzer. So I measured, the buzzer that we had was 11 millimeters and the pitch was about 8. This looks about right. I think this is it. I think this is it. 12. Interesting. So 7.12, 7.6. This looks standard. Let me just check to make sure it's 7.6-ish. Yeah, 7.6. That looks about right. So 12 by 7.6, that's close enough. That's about right. So we'll place that as our speaker. Like there, hit escape, and then the top side of the speaker has to be connected to VCC. Okay. Ugly. It's ugly, but what we did now, we should have just added, there should be 2 functional buttons and a functioning speaker. We're going to save. We're going to design, we're going to update the PCB. Apply changes. Okay, so now, of course, as always, that messed up a whole bunch of stuff. We're going to make our board bigger. Oh, we didn't want to do that. We're going to make our board bigger by clicking this, dragging this down. We can put, now, we might not want a buzzer close to a sensitive, strain gauge amplifier. It'll probably be fine though. It's not that sensitive. Well, it is that sensitive, but yeah, whatever. You know what? We'll give ourselves some space. So we'll put the buzzer here. Maybe rotate it a little bit. Put the buzzer down in the corner. The header's got to be Oh no, did I screw this up? Oh no, it's fine. Looks about right. So buzzer's going back there. The switches, so this one is switch 1. So we'll put that here. This one is switch 2. Put that about here. Okay, now we have some resistors. We have, let's go back to our schematic. So we have R9 and R10. So R9, I'll keep that here-ish. Well, let's put it here. And then R10, we'll put it here. Now, you very likely would want to triple check and make sure all this stuff is aligned. I'm not going to spend that much time. And now we have the transistor here and the resistor. So R11, Q2. Might as well just put that close to here. R11, Q2. That looks fine. Okay, and let's start routing this thing up. Again, grounds we don't really care about, right? If we have a ground, all we're going to do is we're just going to assume the ground pour is good, and we'll make sure of that by taking this ground pour and extending it down. That's right, we had to do this before. That's about right, okay. So we got to get VCC down here. That's kind of a problem. So we got to get VCC somehow down to all this junk down here. There's not. I'm kind of still trying to avoid. Well, let's route up everything. Let's route up everything else before that. H28 here. Now none of this stuff is really high current, so we don't really care that much about a lot of this stuff. Right, none of this stuff is, that's going to go to ground, so we don't care. Now all this stuff has to be VCC. So all these buttons, the top part's connected to VCC, so we'll just run a VCC there. We got to get, somehow, we got to get VCC to these things. So probably what I'll do to get VCC down to these is I'll just take it from here, and I'll route it back behind here. Now the flip side is we could have routed on the other side of the board, which probably would be a smarter way to go. But I'm not a smart man. Okay, so we'll go here, VCC, and then again, I'm trying to avoid routing around the board, so this will be fine. This should be, again, if it's all low power, this is going to be totally fine. As a way to do this. So actually this is not going to be great because we have to get these signals out. So what I'm going to do is I'm actually going to route this wire on the bottom side of the board. So I'm going to delete that. The thing is these are through holes. They're connected on both the top and the bottom. So if I switch to just routing on the bottom and I do a route here. Okay, so now these are all connected. So now the VCC connects to the top side of the through hole here, and then the bottom side of the through hole connects across here. And when we do our ground pour, it should just avoid that. So now we'll go back to doing the top thing. We can connect H7, we can connect H7, we can connect H6, H26. Okay, so now all we have to do is take these signals and route them back to the, you have to route these back to these pins. Is that H26? What? Oh, wait. That's ground. Never mind. Take it all back. What am I doing here? And then we'll route this one up through here. And again, that blue wire is on the other side of the board, so we really don't care about it. It's fine. Okay, and then all this left, I believe, is ground. So we're going to do what we did before. Take a little ground, pop it out. Take a little ground, pop it out. Take, I think we got one more ground here. Take a little ground, pop it out. Okay, and then we will take those ground vias and make a couple of those. Just Control Paste, Control C, Control V. So that gives us a connection to the bottom side of the board, which should be ground. Now what we're going to do is we're going to go to this ground port here and right click it. Oh, click it, and we're going to do rebuild copper area. Okay, that should have done it. So hopefully it looks like our ground has a good connection. Everything's good. Let's do an error check. Check DRC. No errors. Okay, so that means everything's connected. Now we probably want to add silk screen, right? So we got two switches here. So probably what I'll do is I'll go to top silk and I'll just place like a I'll place a text thing that says so this will be, so this one will be torque. Oh, we'll just do this, torque, and then we'll delete this, and then we'll say, let's double click this, let's change the font. Somebody's knocking on my door when I'm not available. And then the width to 0.4, make it nice and fat. Torque. And then this one will be up, like we'll have, let's have this one be down, the other one be up. So we'll just place, what I'll do is I'll just place a, maybe it counts as a track, I don't know. Yeah. Okay. So that's my down arrow. Rotate that in my up. Okay. So if I look at my design, okay. So now I have added two torque buttons, torque down, torque up. I added a buzzer and modified the PCB. So that's the change I made. I have 3 minutes till class. I will let this compile and upload, and I'll see you all there. Thank you.